Hello, welcome to my project called Strategy Pattern Showcase. This project demonstrates the strategy pattern, which is a design pattern used to change the behavior of a program dynamically at a runtime. In my project, I show how different types of vehicles like a supercar strategy and like a supercar and a fighter jet can use the strategy pattern to define their unique travel behavior. Let me just walk you through the code. The first one, it just starts here. It's a vehicle strategy.py. It's an abstract class. This defines an abstract class named vehicle strategy. Concept of this, a class is a blueprint for creating objects. And this class defines a common structure for all strategies. Um, Over here, like defines travel. Like this is an abstract method that all child classes must implement. Over here, we used abstraction. The implementation details of a travel are hidden over here. Like the subclasses will handle them later. Going further, these two are the subclasses which have like inherited from the vehicle class strategy.py, like the vehicle strategy.py. Supercar strategy. Supercar strategy. It just inherited like inherited from vehicle strategy, class supercar strategy, vehicle strategy. Like this class supercar strategy that inherited from vehicle class strategy. Um, like it defines the travel method for supercars. It calculates the travel time using speed and distance. Over here, we have used two concepts, inheritance and polymorphism. As I mentioned here before, it has inherited from vehicle strategy, and we have also used polymorphism. It calculates the travel time using speed and distance. Um, Although the context call travel on the abstract vehicle strategy, the specific implementation is executed over here. And let's just go to fighter jet strategy. So similar to the supercar strategy, this class implements the vehicle strategy interface. The travel method defines a specific behavior for the fighter jet over here. And the next one, vehicles context.py, it defines the vehicle context class which uses strategy pattern. So init, like the class vehicle context init, this initializes the context with the specific strategy. The strategy attribute holds as reference to the current strategy. And a set strategy method, this allows the user to change the strategy at a runtime, making the program flexible. Like over here, it allows to change the strategy at runtime dynamically, making the program more flexible. Like the travel method, this method calls the travel method of current strategy over here. Over here in this vehicle context.py, we have used two concepts, which is encapsulation and polymorphism. Um, the context hides the complexity of switching and execute strategies from the user. Over here, it encapsulates the complexity of switching from this to this over here. And polymorphism, the same travel method behaves differently depending upon the strategies used over here in the same place. And I just go to the main method. Over here, we have imported these three from the specific area, like from supercar strategy, we have imported that. Fighter jet strategy, we imported that. Vehicle context, we have imported that. Let's just define the main method over here. Distance, like in supercar strategy, we haven't defined how much distance it should travel. So in the main method, we have defined like it should, like let's take a distance of 500 kilometer per hour. Um, let's take 500 kilometer per hour. So the main function, it creates a vehicle context with supercar strategy, uh, calls travel to calculate the travel time using a supercar, and then it changes the strategy to fighter jet strategy and call travel distance again using the set strategy. It changes the strategy dynamically, and then it calls travel again so that it will give the output for the fighter jet as well. Let's just run here, run the program, so we can see that it just gives the output saying that like supercar first and the fighter jet. So supercar covering 500 kilometer per hour at 500 kilometers at 350 kilometer per hour on roads. Fighter jet covering 500 kilometer per hour at Mach 2 speeds in the sky. So like it just displays how long it takes to travel 500 kilometers by a supercar and then by a fighter jet. So that's it. Let me just walk you through the class diagram as well. So over here, vehicle context, vehicle strategy, supercar strategy, and fighter jet strategy. In vehicle context, a class that interacts with vehicle strategy, like it holds as a reference to a strategy and can switch strategies dynamically, just like how we have demonstrated over here using set strategy, just switched it dynamically from supercar to fighter jet. So vehicle strategy, an abstract class that defines the travel method, and fighter jet strategy, supercar strategy, these two that were inherited from vehicles strategy and implement the travel method. So that's it about the class diagram. And the key concepts used in this are abstraction, object class, polymorphism, and encapsulation and inheritance. So in vehicle strategy, we have used abstraction, like the vehicle status interface defines a common method, travel without specifying its implementation over here. Objects like supercar strategy and fighter jet strategy are created based on their specific classes and based on the representative, like this. Let's just say these two are the objects. It was created in a specific classes. And then we have also used class. Each class defines specific behavior. For example, the supercar strategy defines how a supercar travels, and the fighter jet defines how a superjet travels. And we have also used polymorphism. The context calls the travel method, and behavior changes depending on the strategy. Um, Encapsulation in context.py. The vehicle context class encapsulates the strategy and hides the complexity of switching using strategies over here. Inheritance, both supercar strategy and in FighterJet strategy, these two have inherited from vehicle strategy.py. And let me just conclude this. The project demonstrates the flexibility and power of strategy pattern by separating behavior from logic. We achieve modularity and scalability over here. The concepts of abstraction, polymorphism, and encapsulation are well utilized here, making the code easy to understand, extend, and maintain. So that's it. Thank you.